For example 1, we're going to use u substitution. And you remember we let u be whatever's in the denominator inside the square root. So du is going to be 14 plus 16x. And as we divide, we solve for dx. So we're going to go ahead and substitute. And instead of dx, we're going to write what we solved for. So notice that we can't cancel anything out, but I can factor out a 2. And if I factor out a 2, then the 7 plus 8x will cancel, and I'm left with 1/2 times 1 over the square root of u du. So to find the antiderivative, I'm going to write this as u to the negative 1/2. So I'm going to add 1. Remember, 1/2 is a constant, so I bring it down, and I'm going to have u to the 1/2 divided by 1/2 or multiplied by the reciprocal. And then don't forget your plus c. And the last thing I need to do is substitute back my u. And u was 14x plus 8x squared plus c. Example 2, I'm going to take the antiderivative. So there's different methods that we learn how to find the antiderivative. We can either use u substitution or integration by parts. So I always try to do u substitution first. So I let u be whatever's inside a function. So du is going to be e to the x dx, and if I solve for dx, I get 1 over e to the x. So substituting everything back, and instead of writing dx, I'm going to have 1 over e to the x du. So notice my e to the x are going to cancel. And now I just need to find the antiderivative of secant squared, which is tangent of u. Don't forget your plus c. And the last thing I need to do is substitute u back. So tangent e to the x plus c would be my antiderivative. For example 3, we can do u substitution, but notice if you do u substitution, you usually let u whatever's in the denominator. So du is 5 dx, and I'm not gonna have anything to cancel. The 5x minus 6 isn't going to cancel, and that's going to be the same thing if I let u be 5x minus 6, the numerator. I'm just going to end up with the same, and the 5x is not going to cancel. So I can't do u substitution, but what I do notice is I'm going to break this apart into 2 fractions. So I'm going to have 5x over 5x minus 6 over 5x. So I have 1 minus 6 over 5 times 1 over x. So now I can take the antiderivative of each of the terms individually. So the antiderivative of 1 is going to be x. The negative 6/5 comes down. The antiderivative of 1 over x is ln of x. Don't forget your absolute value and your plus c. For example 4, I always say you always let whatever's inside the function be u, or whatever's in the denominator be u. So in this case, you have 2 options. You're either going to be let u be ln of r, and or u be r, but only one of them is going to work. Okay. So you always try something. If that doesn't work, then you try something else. So I'm going to let u be what's inside the square root, so ln of r. So du is 1 over r dr. So if I solve for dr, I get r du dr. So if I substitute u back, notice how my r's are going to cancel, and I can rewrite it as u to the 1/2 du. So I'm going to add 1. So I get u to the, oops, I don't have the antiderivative because I already took it. So 3/2 divided by 3/2 or multiplied by the reciprocal. And all you have to do is substitute u back. Okay, so for number 5, I'm going to do u substitution. I'm going to let u be x to the 4th plus 2x squared. So du would be 4x to the 3rd plus 4x. And as I solve for dx, so I'm going to substitute it back. So I get x to the 3rd plus x times e to the u times 1 over 4x cubed plus 4x du. So I notice that it's not going to reduce because I have a 4. So I'm going to go ahead and factor out a 4. And now my x to the 3rd plus x are going to cancel. So I have 1 over 4 e to the u du. So 1/4 is the constant, so I'm just going to bring it down. The antiderivative of e to the u is going to be e to the u. Don't forget your plus c. And then I just have to substitute u back. So u is 4x to the 3rd plus 4x plus c. So for number 6, I'm going to use u substitution. I'm going to let u be x squared plus 1. So du is 2x dx. Solving for dx, I get 1 over 2x du equal to dx. And I'm also going to do a change of variables. So when x is 3, I'm going to substitute it in u. So I get 9 plus 1 or 10. So my upper limit becomes 10. And when x is 0, I get 1. So I changed my change of variables. I go from 1 to 10. So notice how my x's are going to cancel. So the antiderivative of 1 over u, remember that 1/2 comes down. The antiderivative of 1 over u is ln. Don't forget your absolute value. And because I did a change of variables, I don't have to substitute u back. I'm going to have the ln of 10 minus ln of 1. And ln of 10 is just 0. So I get 1/2 ln of 10. For number 7, I'm going to do u substitution. A little bit different. I'm going to let u be ln of x. So du is going to be 1 over x. And x du is equal to dx. So I'm also going to do my change of variables. So when x is e, substituted in my u, I get 1. So my upper limit becomes 1. When x is 1, I have 0. So I'm going to have 2u minus 6u squared all over x times x du. So notice how my x's cancel. So now I can take the antiderivative of each term individually. The antiderivative of 2u squared is 2u over 2. And we have u to the third. Remember, we're adding 1. And we're going from 0 to 1. Because I did the change of variables, I don't have to substitute u back. So I'm going to have 1 squared minus 2, 1 cubed, minus 0 squared minus 2, 0 to the third. So I'm going to have 1 minus 2, which is negative 1. For number 8, since we have a product and we can't use u substitution, we're going to use integration by part. So we're going to let u be logs first, which we do have a log. So therefore dv is going to be x dx. So because our u does not eventually hit 0, we're going to have to use integration by parts. We're going to have to use our formula. So the antiderivative of x is x squared over 2. So if you remember the formula is the integral of u dv is uv minus the integral of v du. So u times v minus the integral of v times du so we're going to have x squared over 2 ln of x minus the integral of x over 2 dx. So if we take the antiderivative, 1/2 is a constant, so I can bring it down. So I'm going to add 1, divide by the new exponent, and don't forget your plus c. For number 9, we're going to use u substitution. Let u be 1 cosine 2x. So du is going to be negative 2 sine of 2x. So the derivative of cosine is negative sine, so that's why it became positive, and then you multiply it by the derivative of the inside. So substituting it back, I get sine of 2x over u times 1 over 2 sine of 2x du. So my sine of 2x cancel. So notice du is a constant, so you just bring it down. And the antiderivative of 1 over u is absolute value, right? Ln of absolute value. Don't forget your plus c. And then finally you just substitute your u. For number 10, first I'm going to deal with the square. So I'm going to rewrite this as x cosine 36x squared. So one of the things that you always do before you do integration by parts, you always try to do u substitution. So you notice if you let u be 36x squared, du will be 72x. So I get 1 over 72x du is equal to dx. So if I substitute it back, so my x's cancel, and then I can take the antiderivative. So the antiderivative of cosine of u is sine of u. Don't forget your plus c. And then we're going to substitute u back. For number 11, we're going to do u substitution. We're going to let u be Or we can just go, okay, we know what the antiderivative of e to the negative 2x is e to the negative 2x. And instead of multiplying by the derivative of the inside, we're going to divide by the derivative of the inside. So we get 1/2 e to the negative 2 minus e to the 0. So 1/2 times 1 e to the second minus 1. For number 12, we're going to let u be the denominator. So du is going to be 10y dy. So 1 over 10y du is going to be dy. So substituting everything back, my y's are going to cancel. So since 1 over 10 is a constant, I can ignore it, just bring it down. And the antiderivative of 1 over u is ln. And I just have to substitute u back. And don't forget your plus c. For number 13, notice if you do use substitution, this would not work. So what you're going to have to do is integration by parts. So I always let polynomials before exponentials be u. And if you notice that if you take the derivative of u enough time, eventually it'll hit 0. So I'm going to be able to use my table. So derivative of x squared is 2x. The derivative of 2x is 2. And the derivative of 2 is 0. So the antiderivative of e to the negative 2 is negative 1/3 e to the negative 3x. The antiderivative would be positive 1/9 e to the negative 3x. And then finally it will be negative 1 over 27 e to the negative 3x. Since we're taking the antiderivative, we're dividing by the derivative of the inside. We have plus minus, and then we cross multiply. So we have negative x squared over 3 e to the negative 3x minus 2 over 9x e to the negative 3x, and then minus 2 over 27 e to the negative 3x. Oh, and we forgot one thing. We need to put a plus c. For number 14, it asks, what is the average value? Remember that my formula for average value is 1 over b minus a of the antiderivative. So we're trying to find the average value over the interval 0, 2. So we're going to solve this using u substitution. So I'm going to let u be x cubed plus 1. So du is going to be 2x squared dx, or 1 over 2x squared du is equal to dx. And I can also do a change of variables to make it easier. So when x is 2, my upper bound is going to be 9. And when x is 0, my upper bound is 1. So notice how my x squares cancel. So the antiderivative of u to the 1/2. So the 1/2 comes down because it's a constant. So I'm going to add 1, divide, or multiply by the reciprocal. And I'm going from 1 to 9. So I'm going to have 1/3, 9 to the 3/2, minus 1 to the 3/2. I'm going to have the square root of 9 or 3 to the third. So 26 over 2. Which is 13. Okay, so that's my antiderivative. But don't forget that we have the 1 over b minus a. So I'm going to have to divide that by 1 over 2 minus 0. So I have 1/2 times 13. So my average value is going to be 13 over 2. For the next problem, we're going to find the slope field for the problem. So if you remember, you're going to take each individual point and find your slope field. So at 0, 0, my slope field is 0, so I'm going to have a horizontal line. And then you just go through each of the individual points and find the slope field. For part B, it says to find the particular solution. So in order to find this, I'm going to have to do integration by parts. So I'm going to have to put anything with a y on the left, anything with an x on the right, and remember that your dx and your dy always have to be in the numerator. So if I take the antiderivative of both sides, I'm going to have ln of y minus 1, because if I let u be y minus 1, du is just dx, or dy, so I'm not going to have to multiply it by anything. And the antiderivative of x to the third is x to the third divided by 3, and then don't forget your plus c. So since we're given an initial condition, I'm going to go ahead and solve for c first. So I'm going to have ln of 3 minus 1 equal to 0. So ln of 2 is equal to c. So when I substitute that into my antiderivative, I get this. So now I'm going to solve for y, and I need to get rid of the e by taking e of both sides. So I can rewrite this equation as multiplication. So notice how this is going to cancel, and I'm left with 2 e to the 1/3 x to the third. And then I get rid of the absolute value by doing plus or minus. I'm going to subtract, add 1 to both sides. Okay, so remember my point was when f of 0 equals to 3, so when x is 0, okay, the only way this is going to be 3 if it was positive. So I don't need the negative, so it's just going to be positive 2. For number 16, it says the decay equation of a certain radioactive element is given by my exponential law, where t is measured in years. What is the half-life of this element? So basically, we just kind of have to do what we know. When t equals to 0, y is y sub 0. And that's how we have that. When t equals, I don't know, so we're just going to make it t, because that's what we're trying to find. Y is going to be 1/2. So I'm going to set 1/2 equal to my equation. So notice how my y sub zeros are going to cancel. I'm going to take the ln of both sides and divide by t. And that should give me 0.433. So in approximately 0.433, we're going to have the half-life of the element. For number 17, we're taking the derivative of an integral, so remember that they're going to cancel, but because the variables don't match, I'm going to have to multiply by the derivative, and then I'm just substituting this into my t's. For b, since I don't have a variable, I'm going to have to break this apart to make it into a variable. So I'm going to have the integral from x to 0. Remember, we're taking the derivative of t minus 1 dt plus from 0 to x squared of t minus 1 dt. So I can't go from x to 0, so I'm going to have to change. And that's how I get my negative. In this, the derivative of an integral will cancel out. So let me just write this. So the derivative of the integrals cancel out. My x matches, so I'm just left with negative x minus 1. Here my derivatives do not match, but all I have to do is multiply by the derivative and then substitute my x. So I get negative x plus 1 plus 2x to the third minus 2x. Number 18 says, use separation of variables to solve the initial value problem. So the first thing I'm going to do is rewrite the problem with dy dx. So anything that has a y goes on the left, anything that has an x goes on the right. So remember that the dy's and the dx always have to remain in the numerator. So if I take the antiderivative of both sides, I'm going to have ln of y equals to ln of 5 plus x. I'm using u substitution, okay, because when u is 5 plus x, du is just going to be dx. So that's why I'm not multiplying by anything. So before I do anything else, I'm going to go ahead and use my initial conditions. So I'm going to have ln of 10 is equal to ln of 5 plus c. So ln of 10 minus ln of 5 is equal to c. And remember, when you have division, subtraction, that means you can divide 10 divided by 5, which is 2. So substituting that back into my equation, I get ln of y is equal to ln of 5 plus x plus ln of 2. So I'm going to go ahead and take e of both sides. So I'm going to write this as two problems. It's the same base, so I can break it apart as multiplication. So I'm going to have 2 times absolute value of 5 plus x. And then I'm going to have plus or minus. That's how I get rid of the absolute value. But you always have to look at your initial condition. Remember, your initial condition was y is equal to 10 when x is equal to 0. So when x is equal to 0, that's going to give me positive 10. So I don't need the negative. I just need the positive.